box. And it's 6 kilograms.
Yes.
And the coefficient of kinetic friction was 0.04 or 0.4.
0.4, yeah.
And it's asking for how
The
the rate of acceleration.
Mm-hmm.
Cool. All right, so this is just going to be a free body diagram type of question. So let's go ahead and start putting in our vectors, keeping in mind that with slope questions, we always make the x-axis the surface of the slope. So instead of being horizontal, we're going to tilt our perspective a little bit, and this will be the x-axis, and the y-axis will be perpendicular. So gravity always acts straight down. So we can call that force of gravity, which is equal to mg. In this case, it's going to be 6 times 9.8, which gives us 58.8 newtons. But gravity is not on an axis, so we want to split it into components so that the components are on the axis. So we know our y-axis will look like that, and our x-axis will look like that. They make a right triangle. We know that this angle up here is always going to be the same as the angle of our slope because they're similar triangles. So we can use that angle and that hypotenuse magnitude to solve for these two sides. So for the y component, I got 45.7 newtons. And for the x component, I got 37 newtons. Is that what you guys got?
Yeah, so the 58.8 is the vector coming straight down.
Yep, so that would be
Okay.
the hypotenuse of this
Got it.
right
Okay.
triangle. Cool. So that takes care of gravity. Everything else that we add on this free body diagram is going to end up lining up with an axis. So that'll be nice. That was the only one that we're going to have to split. So what's the next force that you guys want to add? What's the force that comes that's pushing the box up off of the ramp? Normal force. So normal force, and we know that it's going to be equal to the y component of gravity. And the reason that we know that is because if it wasn't equal, then that means there would be a net force in the y-axis, which means the box would either be accelerating that way or accelerating this way. We know neither one of those things is happening, so this and this must cancel each other perfectly.
Mm-hmm.
So this equals 45.7 newtons, just like this. The last force that we haven't added is what?
Friction.
Friction. So which way is friction going to point? Up the ramp or down the ramp?
Up the ramp.
Good. The box is sliding down. Friction wants to oppose that, so it'll push up. We know that friction is equal to whatever our coefficient is. In this case, it's 0.4 times whatever our normal force is. In this case, it's 45.7. So we can multiply those two things together. We get 18.28.
Mm-hmm.
So 18.28 newtons going up the ramp. So now what we want to look at is the sum of our forces in the x dimension. Because we already know the sum of the forces in the y dimension are 0.
Mm-hmm.
But in the x dimension, we've got the x component of gravity going down the ramp with 37 newtons, and the friction going up the ramp with 18.28 newtons. So the sum is going to be that 37 minus that 18.28. So 18.72. Another equation that we know that involves sum of forces is sum of forces in the x equals mass times acceleration. So we can take this number, we can plug it in for the sum of the forces. We can take the mass of our box, plug it in for m, and then solve for a. Yep, so a equals 3.1. Units on that is going to be meters per second squared. So yeah, that one is all just about being able to do free body diagram, which can be tricky, especially on slopes.
Yeah.